You hear all these terms thrown around: AI, ML, LLM, and if you've ever felt like the world of artificial intelligence is just a confusing soup of acronyms, trust me, you are not alone. So today, we're going to clear all of that up. We are going to demystify this entire landscape, from the biggest, broadest concepts right down to the nitty-gritty tech that powers tools like ChatGPT. Let's just dive right in.
So here's the big question on everyone's mind, right? We hear about artificial intelligence, we hear about machine learning, deep learning, and then of course we're all using tools like ChatGPT. But how do they all relate to each other? Are they just different words for the same thing? Spoiler alert, they're absolutely not. And by the end of this, you're going to know exactly why.
And to get there, we're going to follow a really simple roadmap. First, we'll start with the big picture, what I like to call the AI family tree. Then we'll zoom in and meet machine learning. After that, we'll explore the real power of deep learning and then get into the super important difference between AI that creates and AI that classifies. And finally, we'll figure out exactly where large language models, LLMs, fit into all of this.
All right, first up, let's build a mental map of this world. And the best way to think about it is like a set of those Russian nesting dolls, where each concept fits neatly right inside the next.
So at the very, very top, the biggest doll in the set, we have artificial intelligence itself. And here's the first big myth we need to bust. AI isn't a single technology. It's an entire field of study, just like physics or biology. It's the huge umbrella that covers everything else we're about to talk about.
And boom, this right here illustrates the whole structure perfectly. You've got the huge field of AI. Inside of that, you have the subfield of machine learning. Nestled inside machine learning, you find an even more specialized area called deep learning. And then, way down at the core, within deep learning, that's where we find the tech that powers the tools we hear about every day, like generative models and LLMs. Keep this picture in your head. It's our map for the entire journey.
Okay, so let's pop open that first nesting doll. Inside, we find machine learning. And if you remember just one thing about it, remember this. It is all about learning from data.
So, in a nutshell, what is machine learning? Well, it's basically a program that you feed a whole bunch of data. It chews on that data to train a model, and once it's trained, that model can make some pretty smart predictions about brand new data it has never, ever seen before.
Now, what's really cool is that machine learning comes in a couple of main flavors. On one side, you've got supervised learning. This is where you use labeled data. Think of it like using flashcards with a kid. You show it a picture and say, "This is a cat." It learns from those labels to predict something specific, like guessing a tip amount based on a restaurant bill. But on the other side, you have unsupervised learning. This is where you just give it a ton of unlabeled data and say, "Find something interesting." It looks for natural patterns all on its own, like grouping employees into different clusters without being told what those clusters should be.
So, okay, that's machine learning. But then what's all the hype about deep learning? What makes it so special? Well, let's peel back another layer of our nesting doll. The secret sauce, the real magic of deep learning, is that it uses something called artificial neural networks. Now, you don't need to be a neuroscientist here. The key idea is that these systems are sort of inspired by how the human brain is structured. They have layers of digital neurons that process information, and the more layers you have, well, the deeper and more powerful the model gets. And because of these neural networks, deep learning can pull off some really amazing things, like something called semi-supervised learning. Just look at this bank fraud example. A bank has millions of transactions. They can't possibly label every single one. So what do? They label just a tiny fraction, let's say 5%, as either fraud or not fraud. The model learns the basic patterns from that tiny labeled set, and then, this is the clever part, it applies that knowledge to the massive 95% of unlabeled data. It's just an incredibly efficient way to learn. Okay, now we are getting to the absolute heart of modern AI. Inside of deep learning, models pretty much have one of two main jobs. They either classify things that already exist, or they create brand new things.
And this slide just lays out the difference perfectly. A discriminative model is basically a classifier. You feed it a bunch of labeled pictures of cats and dogs. Its job is to look at a new picture and say, "Yep, that's a dog." It discriminates between the categories it already knows. A generative model, on the other hand, is totally different. It learns the underlying patterns of what makes a dog, and then its job is to create a totally new image of a dog that has never existed before. So one classifies, the other creates. It's a huge difference.
So, how can you spot generative AI out in the wild?
Well, here is a super simple litmus test you can use. If an AI's output is just a number, a simple label like spam or not spam or a probability, it's not generative AI. But if the output is something brand new that it created, like natural language text, a human-sounding voice, a unique image, or a piece of music, then yeah, you're definitely looking at generative AI.
Which brings us to the final, and probably the most famous, piece of our entire puzzle: large language models, or LLMs. So where on earth do these fit in?
So, just like our hierarchy showed us, LLMs are a type of deep learning. And yeah, they are almost always generative. They create text, but the terms are not interchangeable. There's a massive overlap for sure, but an LLM is a very specific type of model that's focused on language, while generative AI is the broader job description.
The absolute key to understanding how LLMs work is this two-step process. They get pre-trained, and then they get fine-tuned. This quote just nails it. They start with this huge general education by reading like half the internet, and then they get specialized training for specific jobs.
I love this analogy. Think of it like training a dog. The pre-trained LLM is like a happy family dog that knows all the basic commands: sit, stay, come, roll over. It's a generalist. It's super smart, super capable, but it doesn't have a specific expert job.
Fine-tuning is what happens next. You take that wonderful generalist dog and you give it very specific, intensive training. And suddenly, it's not just a pet anymore. It becomes a police dog, or a guide dog, or a hunting dog. It's the same underlying smart model, but now it's a world-class expert in a very specific domain. And this is exactly how it works in the real world. A company can take a powerful, pre-trained LLM that already understands grammar and how to summarize things. Then they fine-tune it on their own private data, like a hospital feeding it all of their medical records or a bank feeding it financial data. And the result? You get a highly specialized, expert AI that can help improve X-ray diagnostics or spot financial fraud with amazing accuracy. It's incredibly powerful.
So there you have it. We went from the huge field of AI down through machine learning and deep learning, all the way to these fine-tuned specialist models like LLMs that are really changing our world. The question I'll leave you with is, now that you know the family tree, where do you think the next amazing specialist AI is going to show up? Thanks for joining me.